So let's test this out, see if this works how I want it to this time. So I am using OneNote. I was just trying to mess around with this screen recording software, not really getting the result that I want at the second, but that's okay. We are educators, we are improvisers. Okay, so this is OneNote using the, I just inserted the file from Choiceboard and inserted a 2x2 table. The problem is 9 minus 3, you need an answer. So I would just have my students make little markers in their drawing. I would just have them do dots, but it would be easier to do this with a iPad. 2, 4, 5, 6, 7, 8, 9. Okay, so you have 9, you need to take away 3, and there you are. And then you just have your students count how many they have left, and you can talk about your answer, but you also want them to put their answer in here so that they understand the association with the problem. And then if you want, they could insert a new table for every problem, because I will show you with the next problem that it'll be a little bit different. Okay. So, with the next problem, 8 plus we don't know equals 15. So our end result we know is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so you know you already have 8, so you can go ahead and take away the 8 that you know that you already have, because you're trying to figure out what you don't have. So we can take away this 5, and then 3 more to take away that first 8. And then you can count how many counters you were missing to get to that 15. So that would not be your end result, that would be your missing number. So then you can have your student select this number here that they just found and highlight it so you can go around and check their work, see that they're filling in the right missing number. Or you can even have them fill it in like this, fill it in like this. Okay. This is kind of just an as-we-go type of help here. I kind of like this fill in the blank better. Okay, text mode, delete these out of here. Back to my pen. So I have 16 minus what equals 5? 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So this one, they can kind of start to use their inferences if they want, because you know your end result is 5. But you already have 16, so you can't take away the full 16 that you have here. So you can start by taking away that 5. And that's it. The 5 was your end result, so you have to figure out what you're missing here. And that would be your 10 and 11. Oops, and I didn't even fill this in first. I got too excited. And 5. And then your middle here is 11. and they'll go and fill in 11. And text. Okay. So this one might throw off a student depending on the age of them and how often they've been exposed to backwards numbers, so to speak. So in this problem, this is where this setting up may help them. So you have 7 and 2, and you're still looking for an answer. You're taking 7 minus 2. Because if you move this to the other side of the equation, you're still looking for the same difference. So 1, 2, 3, 4, 5, 6, 7. See, I've been writing these counters in groups of 5 just for an easy visual, and I would advise my students to do the same as well. So we're taking away 2, and we are left with a pretty number 5. And we'll erase these and do the same thing. This is why it would be nice for a student to get in the habit of using something to set up their problem a way that is easier for them to recognize as well. So I am much more apt to subtract to find my answer than I am to add to find my answer. So I have 13, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I already have 7, so I need to find what I'm missing. So here's 5 for an easy visual, and then 2 more. So then you're left with 5 and 1, which is 6. Okay. Last one, we've got an answer of 6 and 14 minus blank. So, again, get my counters out. We have 14, and we know that 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, and we know 6 is our end result, so we can go ahead and wipe out 5 and 6. So then you know you have 5 and 8 left. And that would be that.